Yes, Ashwini. What is the surface area of a circle?
4 pi r square, ma'am.
4 pi r square. Very good. So here we are going to substitute the surface area of a circle in place of ds. So you will get pi equals E into 4 pi r square. So 4 pi r square, after you write, call that as equation 1. According to your Gauss theorem, pi will be equal to 1 divided by epsilon naught into q. Call this as equation 2. So what you can see is left hand sides are equal. I will equate my right hand sides. E into 4 pi r square is equal to 1 by epsilon naught into q. So what you will get here is 1 divided by 4 pi epsilon naught into q divided by r square. See, this general term will be E is equal to q divided by 4 pi r square into epsilon naught. Just for rearranging, we write this as 1 divided by 4 pi epsilon naught into q divided by r square. So you're going to derive expression for a point outside the shell, and it has to be on the surface. Second point, when you are doing at a point on the surface, when you take on the surface, this distance d will be equal to the capital R. Electric intensity, capital E, for the points on the surface of the charged spherical shell is given by the formula E is equal to 1 divided by 4 pi epsilon naught q divided by capital R square. This is the Coulomb's law what we follow. By definition, the formula for sigma, your surface charge density, will be q divided by 4 pi r square. So I can cross multiply these two and get the value for q. So you will get q is equal to sigma into 4 pi r square. So you can substitute here E is equal to 1 divided by 4 pi epsilon naught. In place of q, write this value, sigma 4 pi r square divided by r square. You can cancel out capital R square, 4 pi and 4 pi will cancel. You will only get E is equal to sigma divided by epsilon naught. So this is the second part of your derivation. First part, you will get E is equal to 1 by 4 pi epsilon naught q divided by r square. Second part, you will just get E is equal to sigma divided by epsilon naught. So these two derivations are important for 5-mark question. One is charged wire. The second one is for a spherical shell. Now, having completed this, we will see a few 1-mark questions, or what are the important 1 and 2-mark concepts of this. There's one term to learn which is called as your frictional electricity. Now, what is friction? You take your hand, rub your palm. You can see your hand is becoming hot. So when two objects come in contact with each other for a short time, there's one sort of force which is created, or a sort of energy which is created, which we call it as friction. So this frictional force, in terms of electricity, what is happening, we will just check. Frictional electricity is your electricity produced when you rub two suitable bodies and transfer the electrons from one body to other. So if you rub two objects one against the other and you are able to transfer it from one object to the other object, then the electricity which is produced is called as frictional. Frictional means we should rub one object on the other object. So when we do it, automatically electrons will get transferred from one body to another body. Now look at your diagram. I'm having a glass rod which is positive, and I have a silk cloth which is negative. So if I take the silk cloth and add it up or rub it against the glass rod, you can see from the silk cloth, charges will get attracted towards the glass rod. So what is happening here? Silk is negative, glass rod is positive. When both come in contact with each other and you rub them against each other, charges will get attracted towards your positive and negative charges. That is one frictional force. The same thing, instead of glass, there's one more material called as ebonite. It is a chemical substance which is there. So if you take an ebonite rod and put it on a flannel, flannel is something like a board. What you have, a flannel paper, thick cloth material is called as the flannel thing. So there if you see, ebonite will become negative, the rod will become negative, and the cloth will become positive. So here in the first condition, the rod is becoming positive, the cloth, silk cloth becomes negative. Here rod becomes negative and the cloth becomes positive. So charges can get transferred from one point to the other point. So frictional electricity is nothing but electricity produced by rubbing two suitable bodies and transfer of electrons from one body to the other. These electrons in the glass are loosely bound in it than the electrons in the silk. Silk material has more electrons compared to the glass materials. So when glass and silk are rubbed together, the comparatively loosely bound electrons from the glass will get transferred to the silk. So all the negative charges from the glass which are loosely arranged will come on to the silk. As a result, your glass becomes positively charged and silk becomes negatively charged. Second example, electrons in fur or flannel is the same. When they are loosely bound in it, than the electrons in the ebonite rod. So when ebonite and fur or ebonite and flannel are rubbed together, the comparatively loosely bound electrons from the fur material will get transferred to the rod or to the ebonite rod. As a result, ebonite becomes negatively charged and your fur will become positively charged. In both the examples, whichever is loosely arranged. First case, in the glass, negative charges are loosely arranged. They come onto the silk. The second case, on the fur material, electrons are loosely arranged. So that will get attracted towards the rod. So this is how electrons will get transferred. It is very important to know that electrification of the body, whether positive or negative, is due to transfer of electrons. Positive charges will not transfer, only electrons will transfer from one body to another. If the electrons are transferred from a body, then the deficiency of the electrons makes the body positive. If you remove all the negative charges, automatically that object or that body will become positively charged. If the electrons are gained by a body, then excess of electrons makes the body negative. If there are more negative charges, automatically the object will become negative. If the two bodies from the following list are rubbed, then the body appearing early in the list is positively charged, whereas which is observed lately, that will be negatively charged. So we will take few examples. This is for your 1 mark questions, what you have to keep in mind. Now if you take glass and silk, in that case, glass will become positive, silk will become negative. If you take wool and flannel, or if you take fur, then they will become positive, and all the other things like amber, ebonite, rubber or plastic, they will become negative. The same if you take ebonite and polythene. Polythene is this plastic covers what we have. Then ebonite will become positive, polythene will become negative. This example of your dry hair and a comb. We did this experiment also. You take a comb and rub your hair fast. Then your hair will become positive and the comb will become negative. So this is just for you to keep in mind. If we have glass and silk, glass becomes positive, silk becomes negative. Your dry hair, if you take, dry hair will become positive and your comb will become negative. Wool, if you take, this wool becomes positive and all these amber, ebonite, rubber, plastic will become negative. If you take ebonite and polythene, ebonite will become positive and your polythene will become negative. The next question we are going to see is the properties of charges. last class, we saw what are the properties of electric field lines. Here you're going to see what are the properties of charges. Three important properties I want you to remember. Property number 1, charge is additive. That is your fourth point here. Property number 2, charge is quantized. That is the fifth point here. Third point will be charge is conserved. These three are very important. Charge is additive, charge is quantized, and charge is conserved. In case you forget this, you can write the properties which are above. The remaining can be considered. Very important three is, I'm repeating it, charge is additive, charge is quantized, and charge is conserved. So here, the first property is there exists only two types of charges. One is positive charge, the other one is negative charge. We don't have anything else apart from it. So only two types. One positive, second one is negative. Second property you already know. Like charges will repel, unlike charges will attract. Charge is a scalar quantity. That is point number 3. Fourth one, charge is additive. We can add, see, plus 2, plus 5, and minus 3. Coulomb is the unit. I can add 2 plus 5 is 7. 7 minus 3, you will get it to be equal to 4. So 2 plus 5 is 7. 7 minus 3 is 4. We can add the charges. That's the fourth point. Fifth point, charge is quantized. That is, electric charge will exist in discrete packets, separate packets, rather than in continuous amount. So these small packets can be expressed in integral multiples of your fundamental electronic charge. That is, E is equal to 1.6 into 10 to the power of minus 19 Coulomb. Q will be equal to plus or minus N into E. N can take any number. E value is already given for you. It is 1.6 into 10 to the power of minus 19 Coulomb. Point number 6, charge is conserved. That is, algebraic sum of your positive and negative charge in any isolated system should remain constant. One more definition is, charge can neither be created nor destroyed. It can only be conserved. When a glass rod is rubbed with silk, what happens? Negative charge appears on the silk and an equal amount of positive charge will appear on the glass rod. The net charge on the silk and glass system will remain 0. That is the meaning for charge is conserved. This charge does not have any velocity. Recently, there's the existence of a material which is called as quark. That word I want you to just remember, Q-U-A-R-K-S. Quarks are there. Their charge will be equal to 1 by 3 times E. What is E? 1.6 into 10 to the power of minus 19. And it will always also be equal to 2 by 3 times E. This is recently found out and we call them as quarks. See, you know what are positive and negative charges. Like that, there's one more new formulated compound or material which is found out. We call them as quarks. They will have 1 by 3 times the charge value or 2 by 3 times your charge value. The minimum value of quantum of charge will either be 1 by 3 or 2 by 3. Law of quantization means it should be an integral multiple of E. That is only 1, 2, 3, 4. But now they have found out even lesser than that compounds will exist. Coulomb's law, we've already seen it. This is the statement for your mathematical form. Very important 2 more question. Electrostatic force of attraction or repulsion between any 2 point charges will be directly proportional to the product of the charges and it will be inversely proportional to the square of the distance between them. And they will act along the line joining the 2 charges. Strictly speaking, this Coulomb's law applies only to stationary point charges, not to charges which are in movement. So mathematically you can write F is proportional to Q1, Q2, that is a product of the charges, and inversely proportional to the square of the distance, that is 1 divided by R square. If you combine both, F is proportional to Q1, Q2 divided by R square. remove the proportionality sign and write an equal sign, you'll get F is equal to K into Q1, Q2 divided by R square. K is called as the proportionality constant, and we call it as the electrostatic force constant or Coulomb constant. K equals 1 divided by 4 pi epsilon naught. 1 by 4 pi are constants. This epsilon naught is called as the permittivity of free space. So Coulomb's law mathematically is F is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. If you take any medium, epsilon naught is in free space. If you remove that and write epsilon, K will be equal to 1 divided by 4 pi epsilon. Epsilon is called as the absolute electric permittivity of the dielectric medium. Dielectric constant or relative permittivity is given by the formula K epsilon R. This is called as your relative permittivity. It's the ratio of permittivity in the medium divided by permittivity in free space. So when you take that permittivity in free space, you will get the formula as epsilon R is equal to epsilon divided by epsilon naught. So when we take that expression, K will be equal to epsilon R equals epsilon divided by epsilon naught. So you keep this in vacuum, you have the formula here, only epsilon naught. In medium, F will be equal to 1 by 4 pi epsilon naught into epsilon R. Q1, Q2 divided by R square. This formula you have to remember, value for epsilon naught, it is 8.8542 into 10 to the power of minus 12 Coulomb square per Newton per meter square. And this 1 by 4 pi epsilon naught, you have a value, or in general, we write it as 9 into 10 to the power of 9. That's the value for 1 divided by 4 pi epsilon naught. So today's class, we have seen what is your Gauss law in electrostatics. Then we have seen the derivation for your expression for a wire. Then for a spherical shell, we have defined what is frictional electricity when they move from one point to the other point. And we have seen few examples which will become positive and negative. Properties of charges is one important question, and Coulomb's law is the second important question. Here, what is relative permittivity? So these are the things which we are learning in this chapter. You have any doubts, you can clarify. Yes, any doubts you can ask.